So on this first one, all I want to do is simplify. So the negative sign, I'm going to take it out and it turns into a what?
I.
An I. Very good. So 4I square root of 75. And then what do you do?
75. Then you do a little tree, and it's 5. No, 2 and something. I don't know. 14, I think. I don't know.
5 and 15. Yep. 5 and 15. So we're going to take 75. We're going to break it down. 5 and 15. 15 breaks down to
3 and 5.
3 and 5.
Pair of 5.
So pair of 5s, they're going to go on a date. What has to stay home?
3.
The 3. Okay. What is already on? What number is already on the outside?
4.
A 4. So what do you do with the 4 and the
20.
multiply, and you get 20I. And then what's on the inside?
3.
3. Good.
I did that right. I did that special this morning on my tutorial.
Good. All right, number 2. Simplify the complex numbers by adding or subtracting. I'm going to do B because I want to make sure we all understand what the negative sign does. So, because you're subtracting here, we're going to distribute by negative. So, negative 1 times 14 is
14.
negative 14. And then negative 1 times negative 10I? Positive 10I. So make sure your signs change because of that negative. The plus sign is not going to affect anything. All right, it's the negative sign that always messes people up. All right, from here we're going to combine like terms. So I'm going to combine my two real numbers, 12 minus 14, which is negative 2. And I'm going to combine my imaginaries, negative 2I plus 10I. 8I. Yep. When you combine your like terms, you don't actually mess with the I. The I is just telling you that you can add them up. All right. So it just stays an I. All right. Now number 3. I'm going to do B. So on this one, I have to either FOIL or use the box. You can choose. I like to FOIL. So 5 times 5 is what? 25. 5 times negative 7I. Negative 35I. So that takes care of the 5. Now I have to do the 7I. So 7I times 5 plus 35I. And then 7I times negative 7I. Very good. Minus 49I squared. So you're multiplying now, so pay attention to what has I squared. All right, what do you notice about these inside terms here? They cancel. It's not always going to happen that way, but in this one it does, because negative 35 plus 35, they cancel. And what do I know that I squared is?
Negative 1.
Negative 1. Very good. So just negative 1, the I is no longer there. What is negative 49 times negative 1?
Regular 49.
Regular positive 49. And so then 25 plus 49? 74. Okay, I'm going to help you get started on C. So this squared here. Do not distribute the square. Do not distribute the square. The square means that you have 5 plus 2I times 5 plus 2I. It's itself 2 times. I would start this one. You have one of these on your test. So make sure you know how to do it.
Oh, sorry about that.
I think I forgot to put the answer on the back for C. I put the answers on the back, but I forgot about C. So if you want to put the answer down, it is 21 plus 20I. I'm not going to work it out. I want y'all to try to do it on your own because you definitely have one of those on your test. But all right. So that's how you do it then. Then you'll just either do FOIL or box just like I did in B. All right. Go down to this next step here. All right. Solve by taking square roots. On your review, I told you specific methods to use. because I want to make sure you cover all the methods on your test, you are not going to be able to, I'm not going to tell you, solve by completing the square, solve by taking roots. You have to come up with a way. So I made this like chart up here for you. I'll leave this up for the test if you want. This is kind of all the ways that we have solved quadratics so far. So first of all, depends on whether or not you have a calculator. Here's your calculator. Here's your non-calculator. If you have a calculator, I would just go ahead and graph it. Type it in, set it equal to 0, type it in, menu analyze 0, find your x-intercepts. All right. So if you have a calculator, feel free to use it. Just go ahead, type it in, find the x-intercepts. All right. If you do not have any x-intercepts, your solutions are imaginary, which means they have the I. All right. So if your graph does not touch the x-axis, it means your solutions are imaginary.
So we don't say no solution.
Either answer would be correct, no solution or the solution with I. All right, so here's an example that I did for you. All right, over here, I know this kind of looks crazy. These parts right here, those are just examples of that type of problem. So if you kind of just want to ignore the example so it looks less crazy for you, that's fine. If you have a non-calculator part, you have a couple different options. First, if you have one term that has an x, one term with an x, if I would try to solve using square roots, because that's the easiest way. You just solve for x. But you only can do this if you have one term with an x. So like on these examples here, this one only has an x, that only has an x. So there's only one term with an x. Does that make sense? Okay, so one term with an x, just go ahead, solve for x like normal. If you have two terms with an x, like this guy right here, you have x squared and you have an x, right? I would try to factor first, right? So factoring we did before the break. So here's an example of factoring and solving that way. If you can't factor, the very last resort, I would complete the square. We haven't done quadratic formula, so just ignore this for right now. We're going to do it next week. So far we have done these 4 methods here. If you have a calculator, graph. If you don't have a calculator, see if you have one term with an x. If you have more than one term, see if you can factor. If you can't factor, last resort, complete the square. Does that kind of make sense?
Are you gonna leave that up?
I'm going to leave it up for the test, yeah. So, kind of helps sum up what we've done. All right. On this one, I'm going to do number 7. All right, so one term with an x here, so we can
Minus 160.
just solve. So yeah, so minus 160. 5x squared equals negative 160. Then what?
Square root.
Divide by 5. What is 160 divided by 5?
It's 35, right?
35? No, can't be 35.
Yeah, we do have that.
32?
Oh, no, you're not 32. Yeah, that's what I meant.
All right, 32. That looks better. All right, and then how do you get rid of the square?
Square root.
Square root. Square root. Every time you square root, you have to put a what?
That's fine.
A plus or minus. And then what does this negative sign mean?
Imaginary.
It's imaginary, so I got to put an I. Okay? And then last step, I need to try to break down 32.
Right.
So what two numbers multiply to give you 32?
16.
8 and 4.
8 and 4. What breaks down to give you 4? 2 and 2. What breaks down to give you 8? 4 and 2. And what breaks down to give you 4? 2 and 2. So what do you have a pair of?
2.
How many?
2.
2 pairs of 2s. What has to stay home? This 2. So on the outside, what number is it going to be?
4.
4, because 2 times 2. So plus minus 4i. And then on the inside, what goes in there? 2. The leftover 2 right here. So 2 times 2 is 4. The leftover 2 stays inside. Doo, doo, doo.
So we have to put a plus or minus?
Mm-hmm. Yep. Don't forget your plus minus. Okay, number 8.
Wait, what if did the 4 have to go in front of the I or something?
It could be I4. That's fine. They both need to be on the outside, though. All right, number 8, use a graphing calculator to solve the equation. If necessary, round to the nearest hundredth. So this is, you have a calculator and we're going to graph it. All right, so here we go. Here's my calculator. I'm going to go into the graph. First, you need to make sure all of your stuff is on the left side. So on A, all of my terms are already on the left. So I'm going to take this and I'm going to plug it in to f of x. Don't type in equals 0 because it's going to confuse your calculator. The equals 0 means that you are finding the x-intercepts. So you just type 7x squared minus 4x minus 9. Hit enter. And so I want to find the 2 spots it crosses the x-axis. So menu, analyze, 0. All right, and so then I'm going to scroll until one of them pops up, and I get negative 0.88. And then I'm going to keep scrolling, and there's my other one, 1.46, comma 0. All right. Any questions on 8? Sweet. So now we're talking about the word problem now. The function h equals negative 16t squared plus 123 models the height, h, and feet of a ball t seconds after it is dropped from a building. Round all your answers to the nearest hundredth of a second. Almost all work must be shown for credit. So how long will it take the ball to hit the ground? So I'm not telling you any numbers, but we can infer some things. What can I infer from if I want to know how long it'll take to hit the ground?
0.
What's 0? What did you say 0 was? The height, yes, the height. So because we're talking about when it hits the ground, that is when height is 0. So in place of h, I'm going to put 0. All right. It says round, so we're assuming we have a calculator here. There's a couple ways you could solve this. You could graph it if you want, which I think most people like that way. You could also solve using square roots because you only have one term with a t. All right, but I'll go ahead and graph it because I feel like most people will do that. When you're graphing it, you can't type t in. Your calculator doesn't understand t, so you got to put x. All right, so I got to find my 2 x-intercepts. Menu, analyze, 0, scroll, and so one of them is at 2.77. Keep scrolling, and the other one is at negative 2.77. Now, do I need the negative one? Why? Because time can't be negative, so I don't actually really care about this one. Time can't be negative. You don't have to write that every time. I was just writing it as a note to y'all. All right, so we're actually almost done. On the back says find the missing value to complete the square. So on these 2 problems here, I want to find the value that will make this a perfect square. So I want to find my magical number that will make it a perfect square. Very good. So we're going to first divide by 2. What is 2 divided by 2? 1. So first step, divide by 2. What's the second step? Square it. What is 1 squared? 1. So 1 is my magical number that will make it a square. So 2 steps, divide by 2, square it. Divide by 2, square it. All right. 12 and 13, I want to actually solve by completing the square. So these are probably going to be the hardest one maybe on the test. I don't know, one of the harder ones on the test. The solve by completing the square.
I don't like the ones like where you gotta do like all the work.
Yeah, that's this one. Yep. This is the one you got to do all the work for. My pen kind of bled through, so I'm going to do another sheet of paper. So if I were you, I'd star this one. All right, we're going to use the idea from 10 and 11, and we're going to apply it to an equation. So first of all, I want to get rid of that 15 because it's not my magic number. So I'm going to add it.
Oh, so we wouldn't do like the X thing?
Um,
Like with the 15 on top, 6 on the bottom?
you could try, but are there two numbers that multiply to give you 15 that add to give you 6? No, and so that's why you can't factor it, so you have to do completing the square. But yes, I would try to factor it first on the test, because I think one of them's factorable, one of them you have to do completing the square on the test. All right, so I have x squared plus 6x plus blank equals 15. And if you want to do a plus blank on the other side, because you're going to have to put it on both sides, you can.
No.
All right, so we need to come up with that magic number, divide by 2. And then what?
Squared.
All right. So 9 is my number. I'm going to add to both sides.
X plus 1.
All right, so over here is 24. And now here's where some people are kind of getting confused.
X plus 3 square root.
Yeah, for what's putting over here. The whole point of completing the square is so we can write this guy now as a perfect square. And you think, what two numbers multiply to give you 9, but add to give you 6? 3 and 3. So I have x plus 3 squared, and you should know you did it right because those guys should be the exact same number. And now that you've done this,
3 square root.
you can solve for x by square rooting. Square root. Every time you square root, you have to put a
Plus or minus
plus and minus. And 24 we can break down.
4 and 6.
4 and 6. 4 breaks down 2.
2 and 2.
6 breaks down 2.
3 and 2.
We have a pair of with a 2 and a 3. That has to stay at home. So on the outside, it's going to be a 2. And on the inside, 6. We're going to multiply my two guys that have to stay at home. Okay, and then very, very last step is 2 minus 3. Now you can't combine any of these things, and so you just write your final answer is -3 plus minus 2 square root of 6. All right, so I know they're long steps. I think you only have one on your test that you have to do like the whole process on.
How many questions?
14 questions and a bonus. The bonus is kind of hard though. If anybody can get the bonus, I'll be super, super happy.
So,
I ain't going for it.
What's up?
I barely
So
did it.
the two numbers don't have a pair. You multiply them.
Yeah, multiply them, and they have to stay home because they don't have a date.
So you just multiply them back.
hmm
how would you know like if they're gonna get 2 answers to the problem?
This has 2 answers. The plus and the minus are 2 separate answers. Does that make sense?
Yeah.
So-
Well, sometimes we put like 4 and 8 or something.
Like 4, 8. Oh, if everything is a regular number, no i's, no roots. So, like you're talking about when you have 3 plus minus 2. Yeah. So you see, that's a number. That's a number.
5 and 1.
Yep. So if it was 3 plus minus square root of 2, you can't do it. If it was 3 plus minus 2i, you can't do it. Because that has an I, that has a root.
Okay, so if it's a root or I.
Right. So if you have roots or i's, you can't do it. If it's everything is normal, then you can.
Okay, because if we left it like that, like a 3 plus minus 2 on the thing, it would be wrong.
Yeah, I'd count a little off. I mean, you'd be right, but not finished. Mhm.
I know because I was
And then if it does work out like this, that means it's factorable. So you can always kind of check your numbers that way too. All right, just one question left before we are done. Number 14, which you definitely have a question like this on your test too, so if I were you, I'd star it. If your function has 2 imaginary solutions, then what do we know about the graph of the parabola? Don't look at my answer.
I seen it already.
I know it's on your paper, but think about it. If your graph has imaginary solutions, then your solutions aren't real, right? They're imaginary. So they cannot cross the x-axis. So your parabola is not going to touch the x-axis if your solutions have the I, because they're imaginary. They're made up. They don't exist. They are not on the number line.